Take a look at section 6.7 here. We're going to look at graphing linear inequalities in two variables. I know that sounds kind of intimidating because graphing inequalities in and of itself might seem a little intimidating, but really it comes back to, as long as you're confident in your ability to graph a line, which we spent a lot of time on a few chapters ago, then this section really shouldn't be anything too crazy for you. So example number 1 says tell whether the ordered pair is a solution of this inequality. And so again, it comes back to no different than what we did with lines. Plug this guy in for x, plug that guy in for y. So you have 3 times 2 minus 4 times 0 is bigger than 9. So this is 6 minus 0 bigger than 9. So 6 greater than 9. The answer there is obviously no. That doesn't work out. In part B, when I do it, I get 3 times 2 minus 4 times negative 1 greater than 9. So I have 6. Negative 4 times negative 1 is positive 4 greater than 9. So this says that 10 is bigger than 9, and so obviously that's true, so the answer there is yes. So that's all we're looking at. Plug in your x and your y and see if you get a true statement. Okay, now here is your process for graphing a linear inequality in two variables. Okay, first you're going to graph the boundary line. If it's strictly greater than or less than, you use a dashed line or dotted line. If it's less than or equal to or greater than or equal to, you use a solid line. Okay. Step 2. Okay. This says test a point not on the boundary line, but I'll kind of show you a different method too. And then step 3 is shade the correct side of the line. And all of this will make more sense as we progress through the notes. So number 2 says graph the inequality x is less than 1. So the first thing you have to do is graph the line x equals 1. So when you see this, you're thinking, okay, I got to graph this line, x equals 1. Remember, x equals 1 is a vertical line, okay, at x equals 1. And because it's strictly less than, that means it's going to be a dashed line. So it's a dashed line here. Okay, and now what you're going to do is you just pick any point left and or right of that boundary line. And if you saw in the notes, it said 0, 0 is the most common point to test. Okay, so let's just test that. So if I plug in 0 for x, is 0 less than 1? The answer is yes. And so the graph of this inequality is not only the boundary line, the dashed boundary line, but also you have got to shade in this whole entire side of your graph. Because any point that you pick left of the boundary line will have an x value of less than 1. Okay. Part B here is the same idea. Y equals 2, right, is a horizontal line at y equals 2. And since it's greater than or equal to, that means it's a solid line. All right, and then again, it comes back to pick a point. Okay, let's test 0, 0 again. Okay, if I plug in 0 for y, is 0 greater than or equal to 2? The answer is no. And so I don't shade below the line. I have to shade everything above it. That's kind of the idea here. Okay. So in part C, again, the boundary line is the line y equals negative 1/2 x plus 4. So I'm going to graph that line. Well, it's pretty easy. I know the y-intercept here is 4, so I go up to 4. There's my y-intercept. My slope is negative 1/2. That means go down 1, right 2. Down 1, right 2. So there's my line. I have to determine whether it's dotted or solid, and because it's strictly less than, no equal to, it's got to be a dotted line. All right. And then really, there's a couple different ways of doing this. You could test the point 0, 0 and see if it works out. Okay. Or what I do is I know it's less than, so when I think less than, I think everything below the line. And so without doing a ton of work here, I know that I got to shade the region below it. But had I taken 0, 0, right? So I'm coming back to this guy now. So if I plug in 0, 0, I would get 0 is less than negative 1/2 times 0 plus 4. I'd have 0 is less than, that guy goes away. So 0 is less than 4. Check, that's true. So I have to shade the whole region below. So whatever method works best for you is the one I want you to use. Okay. Part D. Okay. I got to do a little bit of work here to find the equation of the boundary line. So I'm going to use my skills that we've worked on so far this chapter. So 2y is greater than or equal to negative 4x plus 8. Divide everything by 2. So y is greater than or equal to negative 2x plus 4. So there's my boundary line. So positive 4 is my y-intercept, negative 2 down to right 1, down to right 1, down to right 1. And since it's greater than or equal to, that means it's a solid line. Whoops, I screwed that last point up there. There we go. Okay, close enough. And again, you can test your point, or you can say when I think greater than or equal to, that means everything above it. So shade everything above the line. Okay, and again, if you don't like that, okay, pick the point 0, 0. All right, plug it in. 0 greater than negative 2 times 0 plus 4. 0 is greater than, that's just 0. So 0 is greater than or equal to 4. That's a false statement. Therefore, you shade the whole region opposite of where 0, 0 is. Either method's going to get you the same spot. Okay, part E is very similar to part A, so I'm not going to do that one. Graph x equals negative 3 with a solid line, and then determine which side to shade. Same thing here in F. Okay, you can do that one on your own. Whoops, why did I go back? All right, so in G now, a lot more legwork to be done here. I'm going to distribute this guy first. So I have y minus 2 greater than or equal to negative 1/3 x minus 1. Add your 2 to both sides. So you get y is greater than or equal to negative 1/3 x plus 1. So there's your boundary line. So go to plus 1 as your y-intercept. Down 1, right 3, right? Because it's negative 1/3 slope. And then it's a solid line since it's could be equal to. Apologize for that. Let me fix that real quick. All right. Let's see here. Let me go make sure my line's pretty accurate. There we go. Okay. So there's my boundary line. It's a solid line. And then, again, you could test 0, 0, or since it's greater than or equal to, that means shade everything above it. Part H, again, rewrite this thing so that it's in y-intercept form, so or slope-intercept form, I should say. So negative 3y less than negative 3x plus 9. Divide everything by negative 3. Our rule still applies that if I divide both sides, everything by negative, I've got to flip the inequality. So I have y is greater than x minus 3. So graph your line. So here's x minus 3, slope of 1. Oh, and I actually screwed that up because since it's strictly greater than, it's got to be a dotted line. So negative 3 is my y-intercept. Slope is 1. And the reason for the dotted line is that anything that lies on that line is not a solution. Okay, and that's why. So, and then again, just pick, you can pick the 0, 0, or since it's greater than, that just means shade everything up above the line. All right. So again, I think that hopefully this is pretty straightforward. If you understand how to graph lines, then this particular section should not be too troubling for you. As always, if there are issues, have questions ready to go in class, and we'll make sure that we clarify.